All right. This is very, very short, 10, 15 minutes. And then we can enjoy the feast. Wow, there is a feast. What is that?
Turkey.
What is that? Wow.
That's why I ran out of the mouth. I had to run home.
You had to run home?
Yeah.
Oh my. Okay. All right. So the last bit about matter we don't want in our food is the filth. We really don't want those in our food. Extraneous matter. So filth is anything to do with animal or insect. And then we have extraneous matter that is non-animal and insect, like soil, glass, metal. You don't want that in your food. So, you know, we can't, they're everywhere. The population of rats is just there. We can't get rid of them. They have the ecosystem. And then there is the insects and parts of insects and birds, as well, feathers. So these are stuff that no matter what we do, they're gonna wind up in the food we eat. There's also the non-filth, the stone, sand, dirt, metal, glass, etc. All of this is referred to, all of these are fall under extraneous matter. Okay, so insects can be eaten. That's why it's a problem here in the US when they say insect protein. Well, they consider it extraneous matter. How can I use them in food if we're gonna, count them as stuff we don't want in food? So it starts from the field. We get those insects from the field, not just insects, rodents and birds. In the storage silos, we will have insects and rodents and birds. During transportation, we might be carrying stuff with us, and also during processing. So everywhere there is a chance to get contamination. And if we look at in the field, insects kind of live on those grains, and when you harvest those insects with your grains. And then in storage, you have these little guys. They are going to come for the grains, and they're going to shed their hair. They're going to have some urine and some pellets, inevitable in our food. So there are regulations. So they are inevitable. No matter what we do, there's going to be some in their food. So we came up with regulations to limit the content of filth and decomposed matter in our food. We came up with good manufacturing practices using sanitary conditions to kind of limit how much we end up with. Thorough inspection of raw material and also sanitation during the whole process. However, no matter what, you're gonna end up having some of that in the food. But we have defect action levels set by the FDA. So they allow us to have 30 insect fragments and 1 rodent hair per 100 grams of peanut butter. Nutritious protein. And then 75 insect fragments and 1 rodent hair and 50 grams of flour. Imagine how much bread we eat per day, how much you're consuming of insects per day. But all good. This is just for laughs. This guy noticed a sudden increase in hair, the barbershop. Hold it, this one has 7% insect parts. So, filth. So these are the terminologies. So we have filth, animal contamination or other objectionable matter. Heavy filth, so sand, soil, excreta pellets, these will sediment, basically, they're heavy filth, so we rely on sedimentation methods to quantitate them. Light filth, so particles that float, like hair, insect fragments, and you usually oleophilic. That means they have affinity to oil. So sometimes in the methods for light filth, we use oil to kind of separate them from the aqueous. So they go into the oil fragment. Filth that you can sieve out. So you use different sizes of sieve to get rid of potential insect parts or pebbles or sand or what have you. All right, so the problem with these methods, sometimes it's very subjective. If we are counting, we need to rely on the experience of the person that is counting. Are they going to recognize the fragment of an insect? If it's a fragment from the outer skeleton of the insect, it might be small, you won't be able to recognize that it is an insect cuticle, for example. But these, of course, you can recognize that this is from an insect, the mandible. All of the methods has transfers, repetitive transfers. So you might lose some content, so therefore you might underestimate. And also there's a problem with counting. So one insect is counted as one fragment of an insect is counted as one. So that's currently the issues of these methods. Few examples. So you use sieves, in this case, for spices and condiments. You use sieves, your spice will go through the milled spice, and then contaminants or extraneous matter will remain on the sieve. You put it under the microscope, and you count how much you have, and then you calculate per gram, per 50 grams, per 100 grams. Heavy filth by sedimentation. So this is mostly used for nuts. We defat with solvents, and also the presence of solvent and carbon tetrachloride. The nuts itself will float, those will float. And then any remaining shells and heavy filth will sediment. And then you separate the sediment, you weigh it, you count it, or you ignite it. That means you put it like you do ashing and weigh. So take the weight. So either you just count, or you just put it in for dry ashing like we do for ash and take the weight. This is an example for counting insect fragments and rodent hair in rye flour. So this is a special flask, Wildman flask, the name of the person that developed it. So basically you have a flask, and then you have a specific size neck, and you have a cork that fits that size of the neck. So what you do is you do that some digestion with acid. So all of your organic matter will remain in the aqueous. You use tween and EDTA. So if you have any brand, with also the tween and EDTA will weigh them down and keep them in solution. And then you add oil, mineral oil, and then any insect fragment and rodent hair would have affinity to the oil. And when you bring that fork up and it gets stuck here, the oil is trapped. And you take that oil and you filter it using vacuum filtration, and you get whatever is on the filter paper, you put it under the microscope, and you count. Light filth, so that was for flour specifically, flotation method. In this case, what you do is you also have an organic phase and an aqueous phase, and use a separation funnel. Your insect fragments and light filth will be in the organic phase. You separate, you filter out, and again, you count under the microscope. Kernels, before you mill, you have to make sure you don't have a lot of larvae. These are insect larvae growing in there. You're allowed to have 32 kernels in 100 grams of seeds that can have those insects in them. the way you count them, you do an X-ray, and then you take a certain amount of grain and then count the infected ones. You can also, other techniques, you measure uric acid to determine the presence of excreta. You use ELISA to measure a specific insect protein called myosa. NIR microscopy would determine different types of metals. If you have also differentiate glass from plastic from other crystalline contamination. Lastly here, so you can do prevention. If you do an X-ray and you found a lot of larvae in your kernels, what you can do is you can crack them open and have blow air on them so that the insect parts will be blown off. If you want to get rid of stones, pebbles, sand, you have like grains or seed, you put them on a belt, and the belt has pores, and you have air from the bottom, so they float, and then anything heavy will remain on the belt and be disposed of. This is what I said about breaking the wheat and or the kernels and do aspiration to get rid of the inside insects that are living in there, and then goes through magnets to get any metal. So you put your samples on a belt and they go through magnets, and then the magnets pull metals. And that's it. Congratulations, we finished with analysis. It was a pleasure, you guys. Have a happy holidays ahead of you, and let's enjoy the feast. Come on, do you want to say a few words? I said, come on, I'm recording. I'm recording. What advice do you have to your young fellows in the room?
Eat good food. It's not worth eating bad food.
Wow. Yeah. Where are you going next, Isaac, after graduation?
Redhead Creamery.
You already have a job?
2 hours west of here.
Great. And we already know Kevin has a job. Medora, what are you doing? You want to go to grad school?
No. Yeah, I'm kind of just trying to figure out. I'm just continuing my true jobs I've been having.
Come work in the lab for us if you don't know what you want to do. We're recruiting, right, Brittany?
Yeah, we'll hire you.
Yeah, this is how I get my students. All right. You want to cut the turkey?